Hey there everyone, we're back with example 3. Here we're going to learn how to do something called eliminating the parameter, which is where we take parametric equations, which usually show up as two equations for us at this point, and how to make those into a single equation. So we're going to do that with our plane curve from example 1. If you remember, these were our equations from example 1. So how do I write this as a single equation? So there's a number of ways that we can do this, but the trick is finding the easiest one. So first thing I'm going to do is I'm going to solve y equals 2 plus t for t. This just involves me subtracting 2 from both sides. Okay. Now substitute. So basically what I'm going to do here is replace t with y minus 2. So I expand y minus 2 and I have my equation that defines the curve. And if you remember from before, we had this produced a sideways leaning parabola. This parabola, actually you can see it right here if you know vertex form, so-called vertex form. You can see that that's a parabola on its side with a vertex of, would be x, so it'd be 1, 2. So I think if you look back at the image from that problem we did first, that's exactly what we see there. Now, remember, this was graphed from -3 to 3. The endpoints of that original equation were at 10, -1, and 10, 5. So these y coordinates, these now, we can translate these to -1 to 5. Those could be my constraints on y. In addition to the picture that we used, seeing that y was going from -1 to 5 when t is going from -3 to t, you can also see this in the algebra here. Y equals 2 plus t. So if you apply that to both of the endpoints, you can see that -3 will go to -1 and 3 goes to 5. You do have to be aware that that doesn't always work depending on the function that you have. It works here because y is an increasing function. It would also work if it was a decreasing function, but that wouldn't necessarily work if you had a function that was not strictly increasing or decreasing. So that's why I wanted to show you the graph too. So you can't always just map the endpoints according to y or x. But if you also are looking at the graph at the same time, then that'll, okay, I will see you in the next video.